All right, question 20. The figure on the left above shows a wheel with a mark on the rim. The wheel is rolled on the ground at a constant rate along a level straight path from a starting point to an ending point. The graph of y equal to d of t on the right could represent which of the following function, which of the following as a function of time from when the wheel began to roll. Okay, so we have a wheel like this, and we have a dot, okay, on the top. Okay, and it started rolling, and then this is the graph. So we know on the x-axis is time. Okay, so as time increases, we have this kind of curve, right? It goes down and up, down and up. Okay, but we're trying to figure out what does the y value represent. Okay, because we're trying to figure out the meaning of this function, right? So what y represent here. All right. So let's think about, if you go through the answer here, let's think through this, right, and see if that makes sense or not. Okay, so A says the speed at which the wheel is rolling. So if you think about the speed, will the speed go down and up and down and up? If you look at the question here, right, it says from the word problem here, it's told us that it is a constant rate. Okay, so constant rate means that we're rolling at a constant speed. Okay, so it's the same speed. So if we're gonna graph the speed, it won't be this kind of curve. It should be just a flat line for the speed. Okay, because it's a constant speed. So as we go to the right, okay, as time goes on, the speed will maintain the same. Okay, so it won't go up and down. All right, so it's not A. Okay, so it's not A. And then we try B. B says the distance from the wheel from is starting point. So if this graph represents the distance, see how as the wheel spins, right, the distance will increase because it's traveling further and further away from the starting point. But it won't go up and down, right? So the distance will just keep on increasing. So it should go just like that, right? Okay, it will be a straight line and we're starting from 0 and then we'll just go up, right? That will be the distance. Okay, so if we're gonna graph the distance, it will be this kind of curve. So again, it won't go up and down, okay, because we're not going backwards, right? Okay, we're only rolling forward. Okay, so it's not B, right? So C says the distance of the mark on the rim from the center. Okay, so this is a little bit tricky. So if you think about the mark from the center, right? The distance from the mark to the center is the radius of the circle here, right? So as the wheel is turned, will that distance change? I know, right? No matter where the mark is, it could be above, could be below, but the distance from the center here will be the same, right? It will be the radius of the circle. So if you're gonna graph that, again, it will be a horizontal line because that's the radius. Right? So radius will be the same. So no matter how it turns, that distance won't change. Okay, so it's actually not C. Which lead us to D, right? D should be the answer. It's the distance of the mark on the rim from the ground. Okay, so you see as it turns, so initially we're starting the point right here, right? The mark is high above the ground. Yeah, here is the ground. So this distance is that much. Okay. And as this road, right, this point will shift over and will get lower, right? And eventually when we get to this position, the point will be on the bottom. Right. And again, as it turns, the point will go up again. Right, so we see this kind of pattern, right? So it decreases and then go up and then decreases again and then go up. And that matches with the point. So this, you're gonna graph this distance, right? That should match with this graph. Yeah, so it go down and go up, down and up. As the wheel turn, the point gets lower and then higher, lower and higher compared to the ground. Okay, so for number 20, our answer should be letter D.